Welcome to the Boston Echo Boards Review course. Today we'll be discussing another question that relates to the physics workshop of the Boston Echo Boards Review. In this sample question, question will be flashed on the screen for about a minute with 4 possible choices. You'll have 1 minute to answer the question, after which the correct choice will be highlighted, followed by a brief discussion regarding the concept that was presented in that question. Enjoy. So this question relates to ladder resolution of beam width artifacts. So the assumption during transmission and reflection of a sound wave is that all echoes have originated from the central axis of a solitary razor-thin ultrasound beam. Well, that's not the case. In reality, all echoes have originated from the full thickness of a 3-dimensional beam, as well as from secondary beams, that is the side lobes or gradient lobes. The consequence of this violation of this assumption of a razor-thin beam is that when a structure is detected from anywhere from within the 3-dimensional beam or from secondary beams, an echo will be produced and displayed as though it has generated from the center of the beam. So let's look at the beam width artifact. That's when 2 reflectors lying side by side. In the beam appears a single reflector, which is sort of a little combination of their individual widths. So for 2 reflectors to be displayed as a distinct entities, they must be separated by a distance greater than the beam width. While we're talking about beam width, in actuality what that means is the scan lines, which means if 2 scan lines are passing, the distance between 2 scan lines is more than the distance between the 2 reflectors, they will be shown as a single reflector. That's a deterioration of the ladder resolution. So a narrow reflector within the beam appears wider. That's what it looks like. And as you can see in this animation or graphic on the left side, that there is one reflector can appear as a small circular reflector appearing as a flat reflector. As the beam sweeps through a dot reflector from the left to right, the dot reflector retains and remains within the beam and will generate an echo and will be appearing wider than it actually is. So width of this reflector equals the beam width. That's what it comes down to. So also beam width artifacts relate to strong reflectors to the side of echo. Free space appear within the beam, and that's how they appear in the image, with one edge being very sharp and other being very blurry. So when strong reflectors are detected at the edges of the ultrasound beam, an echo is generated. The system assumes that the echo has originated from within the center of the beam and places it as such during the process of reflection and creation of the image. With this kind of artifact, the structure generating the artifact is always seen adjacent at the same depth as the original reflector. That's the key point over here. So the depth or the distance from the beam, from the reflector to the ultrasound transducer is always the same. So at the end of the day, this is what it relates to. That is the lateral resolution, that is beam width resolution. And the answer that lateral resolution answers is, and the question that lateral resolution answers is, that what is the minimum distance between 2 structures positioned side by side that can be apart and still produce 2 distinct echoes on an ultrasound image. And that relates to beam width or the distance between adjacent scan lines. Thank you very much.